Hi and welcome to the 5th episode of my tutorial series on AWS using CDK TypeScript. My name is Faruk and I will be guiding you to the basics of an API gateway. Before we get started, I want to thank everyone that subscribed to my channel. I reached over 100 subscribers, so thanks a lot guys. And if you're not subscribed, consider subscribing to my channel or liking the video. And let's go on to the agenda. So the goal of this video is to implement an AWS API Gateway using CDK TypeScript. And before we get started, we're gonna have a look at what is an API, what is an API Gateway, and then we're gonna create the API Gateway CDK stack with the Lambda resolver and authentication and models and whatnot. And finally, we will end the video by testing the API Gateway with some calls from Postman to demonstrate that it's all working. So let's start with the API Gateway, and the first step will be looking at what an API actually is. And AWS actually gives us a definition, and the definition provided by them is API stands for Application Programming Interface, and that's a mechanism that enables two software components to communicate with each other. And they use a set of protocols and definitions in these communications. We'll also cover them in the sample app that we will be creating. So now that we have a general understanding of what an API is, what is API Gateway provided from Amazon? Well, it's a managed service that Amazon provides us, which is actually just an API managed by them, for creating, publishing, maintaining, monitoring, and securing REST and HTTP, but also WebSocket APIs at any scale. So, as I said, API Gateway gives us three flavors of APIs, and these are the REST API, the HTTP API, and the WebSocket API. If we have a look at the first two, REST and HTTP, they are both RESTful APIs. They are pretty similar, but there are some differences. For example, REST has some advanced features, and we'll use one of these features in the sample video, but HTTP is a bit cheaper and also has less latency. And I wouldn't say that REST is better than HTTP, they just have different features, and I will also add a link in the video description with all the features, just an overview of them. And before creating an API, just have a look at these features and create what you need. For example, if you don't need these advanced features, they do induce the latency and cost. So at some point maybe HTTP is the better choice, but if you do need the features, then just go with REST. And finally, we also have the WebSockets API. And the WebSockets API is a little bit different. The WebSocket API is a way to enable two-way communication between the client and a remote host based on an opt-in from the client. And a good example for a WebSocket API would be a chat app. And I know that AWS also has a nice demo chat application which uses the WebSocket API. It's a good example to look at if you want to have an example. We won't be covering that in this tutorial. So what will we be covering in this video? We will be creating a REST API. And the reason why we're creating a REST API is because we're going to use an API key, and that's one of the advanced features. In the last videos, we created a Lambda, and to trigger the Lambda, we logged into the console and we created the test event. And based on the test event, we checked if the Lambda was functioning. Well, this video, we want to trigger the Lambda, but we want to trigger it from my computer or any client or anywhere, so through the internet. And this is where the API Gateway comes in. So the API Gateway will act as a bridge between the internet and the Lambda. We will send a request with a certain protocol and definition to the API Gateway. It will also contain routes for open requests, so we don't need the API key to call those. But it will also contain a couple that you do need the API key. The API Gateway will check if we're authorized to make the call. If we are authorized, it will forward our request to the Lambda. Lambda will then do its business logic and give a response back, and the API Gateway will relay this message back to our client, which will be my computer in this case. So that's what we're going to create. You can of course also have more integrations with the API Gateway. You could, for example, also have a queue as SQS or a step function or anything else actually, but we're not going to do that. We're going to focus on the Lambda integration. And yeah, so let's start building, I guess. So I opened an empty directory called CDK TS API Gateway. This is where I will be creating my stack. So let's initiate the command CDK init language TypeScript, and it will build our CDK stack. Well, the template in here. And in this video again, I will be copying some stuff in just to save some time. And to be honest, I like making these videos, but I don't really like editing so much. So that's why I try to minimize the time that I have to edit, and I try to copy and paste. If you really would like to see the coding process as well, leave a comment and I will think about it. But for now, I just try to do it as this. So the install is done. And just like last time, let's first make some changes before we get to coding. First thing that I will do is I will add a line here saying out dear dist, and just like last time, it just causes the CDK templates not to be distributed through all the folders, but it will create a new folder called dist, and it will output our build files into that folder as well as our CDK code. So now that we have that, I'm gonna create a new file, and I'm gonna call it stackconfig.ts, which will hold all the values that would be variables, so I can change them in one file. And I just do this. We don't really need this, but I just do it because it's just gives me a nicer overview. But like I said, you don't need to do this. But if you're using multiple environments, this would be the way to do it. Because that way you can have like different config files for each of your environments, and you don't have to hard code it like into your stack. Oh, shit. Okay, I get distracted while talking and typing. Sorry. Okay, so we have a stack config and a stack config types. Let's actually start with types. And I will paste them in, and then eventually we'll go through them and I will explain exactly what they are doing. So these are the types. And then also let's add the config. And when we go through it, it will all make sense. So as before, the types will just define what each variable that we're entering has to be, and we have its definition of the types that we're entering into the stack props, as we are extending the CDK stack props with our extra props. So the stack will expect these props, and we can enter them, we can access them through the stack props. We do have to add them here. So the name of the type is this, and in the lib we will be replacing the CDK stack props with the props that we just created. Okay. So now let's go to the stack config and let's have a quick run through, but we will see each of these variables come in the lib in a bit when we start to create our components, but let's go through it. First, we just have some tags. These are optional. You don't have to put them in, but if you do put in tags, they will be on the component. For management, it's just easier probably if you do put tags, and especially if you want to keep track of your cost in a big company, you probably have to put tags. Next, we have some Lambda variables. So we have a name for the Lambda, a description, the amount of memory that we want it to have, and the timeout period. You could have extra things. For now, we're just keeping it simple, but you could also have like provisioned concurrency or anything else. You can have like tracing on, or you can add a Lambda layer, but for now, we're just keeping it as a simple Lambda. And then we have some properties for the API. I'm storing the name here, the description. We're going to create a model also. It's also optional, but we're going to do it. And I'm going to create a root resource that's called v1. For example, if I also have a v2, I don't have to change everything. I can just change this resource. Then we have a usage plan, and what the usage plan is it's a way to manage API keys, and we will come to it later, but it's just, for now, let's just think of it as a way to manage the API and the calls that the API key is entitled to. So the API key, we're just going to give a name and a description, and then we have some validators, and the validators will validate each something different. So we have a body validator that will validate if a request that we're getting into the API has a body, and it has to validate it against the body. That will be the model that we'll be using. Then we have a parameter validator. This will validate the parameter in the request. So we'll get to it if you don't know what it is, but that will validate that one. And we have a validator that will validate both the body and the parameter. So those are also all the components that we're going to use. And we're going to create them here in the lib. And now that we have our stack props in there, we can access each of these values through our props value. So that's what we just did. We have our types, we have our config. Then let's start building our stack. And I will start copying in it and just explain what I'm doing here. So first, let's actually maybe first import our dependencies. We will be using a Lambda, and we will be using API Gateway in this tutorial. So those are all the dependencies that we need. So I'm creating a Lambda here. I'm giving it the function name, the description from the values that we just saw. The handler is this is where the code will be. So in the index file, index.ts, we will be creating this later. It will have a function called handler, and that will be the Lambda code eventually. The location of the code, as I said, we just adjusted the ts config so that it will export it to the dist file. And there it will be in the source, as we will creating a folder called source. We have the runtime and the memory. The runtime, you can adjust it also to a lower one. Just notice that some versions get discontinued, so it's always best to keep it as high as you can. The memory size default is, as you see, 128. I've upped it a little bit. So if we look what I'm doing here, I upped it to 256. You don't have to do it, actually 128 is also fine. I just changed it to show it. And then we have a timeout period. And the timeout period I set is 30 seconds. You could also do it higher if you want, but 30 seconds should be fine for now. Once we have our Lambda, now we're going to create a Lambda integration. So a Lambda integration is something that the API Gateway can use. And the way that we do it, we just say new API Gateway from the resource and the Lambda integration, and we pass in the Lambda that we just created. And now we can use this as a way to resolve API requests. But that will follow in a bit. So now let's create our... I hate it when it's not in line. Okay. So we create our API Gateway here. And we're just going to keep it simple here as well. We're creating an API, we give it a name, a description. We allow the calls to come from everywhere. If you want to, for example, only set it to your website, you should put the origin here. For now, I'm going to say everywhere is okay. And I'm going to allow these methods. So we will be using, like I said, a set of protocols and definitions. Well, the get method, the post method, the patch method, and the delete method are examples of this. And I will go through later what each of these will do. But for now, know that those will be the ones that are allowed, and other requests in this case will be denied. Then we're going to create a couple of request validators. Validators is a type. I have to also import that one. As you see here, it just contains the name. It will contain a boolean for if it should check the body, and it will also contain a boolean for if it should check the request parameter. And then here I have the values for it, like I explained earlier. So this is just a function to create them, and then we just have to create each of these still. So I'm gonna put them in. Now that we have our validators here, they are also ready to be put into the API. And now I'm gonna do something, and by the way, these are actually also optional. You don't need to have the request validators. If you only make an API, it will also work, but we want to use some advanced features now that we're using the REST API. So let's do that. So the next thing that we're creating is a model. And what we will do with the model is the model will describe how a request to the API should look like. So in this case, we're creating a model, and the model will have a name. We put in the REST API where the model fits in, and then we give it a schema, as a JSON schema in this case. And as we see here, it will require a field called name. So if we're sending, well, here you see the object actually. So we will be sending a request, and the request will contain an object, and the object should contain a key called name, and it should be of type string. So we're expecting a name, like the last episodes we put in a good job and then your name. Well, in this case we're going to do it with the model, and to be sure that we can handle this request, we're saying that if the request comes in and we're validating with the body, we want it to be validated against this type of request. And if it doesn't fit the kind of request that we're expecting, then we're just going to say we don't accept this request. So that's what we're going to do here. Then most of the pre-work is done. So I'm going to add a root resource. And a root resource, what is a resource? So an API is like an endpoint, and a resource which you add is / something. So in this case it will be our domain name / v1, because the root resource that I'm adding here is v1. We see it here. And for each resource which you add will be just another / and then the resource name. And this could also be a parameter. And we will also cover a parameter. So just a moment, we have the root resource. And now the root resource, we're not going to add any methods to it. So we're not going to call the v1 endpoint, but we're going to add something to that resource, which will be open. And open will cover all the requests that actually don't need an API key. You can just call these endpoints and it will give you a response. And if you want to call an endpoint that you want to secure, which we'll be making in a second, then you do need to provide an API key. So let's look at what we're adding to the open resource. So we have the /v1, we have /open, and to open we're gonna add a couple methods. And what is a method? A method is just, like it says, a method to call the API. And we're giving it a get method, a post method, a patch method, and a delete method. And I will add a link about these methods and which methods there are, but we're going to use the get method to get something. We're going to use the post method to send something to the in every case we're going to send something, but in the get case you use it if you want to get some information. Post you use in case you want to give something or post something, save something in the server. The patch will be for changing, and delete is just to delete stuff. So that's just the easy way to say it, and we're giving it an operation name. And what this will allow us to do is call this endpoint with each of these methods, and yeah, they will give a response. If you don't have these methods, you can actually not use it on that endpoint because they won't be created. So now that we have all our open ones, because we're not going to do really complicated stuff with the open ones, then we're going to create a couple secure ones. Oh, I'm sorry, I'm pressing auto functions for hiding the index. But we're going to create a couple secure resources. So to the /v1, we're going to add another resource. So instead of v1 open secure, we're going to have two endpoints now. We're going to have like v1 open, v1 secure. And to the secure one, I'm also adding a parameter. And I'm adding these in parentheses. And what that means is that this will be a dynamic parameter. So we won't have /v1/secure/parameter, but this will be something that I fill in. So let's say that it's a name, then it will be /v1/secure/Faruk, and Faruk will then be interpreted as the parameter in that call. That's what these do here. Okay, so for the secure one, we're also gonna add a couple calls. So what are we gonna add? First, let's add a get. The get will get secure resource, so we do need the API key here, and that's how we add it. We haven't created the API key yet, but in the method we specify whether this method requires it or not. So as you see here, we don't have a requirement, so that means no API key will be required when making the call. Then, as we have our get, let's also make a post. And when you're doing a get, you just make a call and you expect to receive something. When you're making a post, you also expect that you're sending something. So in the post request, it looks a little bit different. And before I go over this, this integration is the Lambda integration that we created here. So this is the place where you also add the Lambda that will actually resolve this request. You can also add different Lambdas here. You don't have to redirect them all to the same Lambda. I will be redirecting them all to the same Lambda, but you can just create a second one, a new integration, and you can have the integration run those methods. So just like the get method, we also put the add method on that resource with the post method. So this is where we define the method. Then the Lambda, as I said, a name. We also require an API key, but in this case, we will also validate the body of the request. So the body should contain a JSON, and the JSON should confirm to the model that we created. So what does this mean? It should have a name in it and a string to the key. So let's also add another method, and that will be for the get and delete, but we will add these to the parameter. So we added now the get and the post to the secure resource. So this is /secure. But now we also want to add it to the parameter, because when we add something in there, we also want to do some methods, and we will do the get and the delete. And here we add some different parameter validator. So this will not check in the body. It doesn't have to have a JSON request. It has to have a parameter. And the validator that we created earlier is really simple, just as a boolean that says true on validate parameter. And the request parameter that needs to be checked, so it's the path and num parameter. And we just put it on true. So that's all that we do. Now this request will check if the call has a parameter in it. If it doesn't have a parameter in it, the call will be rejected. Then I think we only have the patch method left. So also add the patch method. And in the patch method, we also expect the request to have a JSON file in it. And the JSON file We'll use the same body, so the same model that we created here. But you can imagine that maybe you need a different body for the different kind of request. You can just create a new model, create a different sort of pattern or a schema, and then just add it. In my case, just because I'm showing just how it works, I'll add the same model. But in this case, we're also expecting a parameter. And so we will do both the parameter and the JSON body will be validated. And this is how we do it. So we have a separate validator that has Boolean true for both of them. Then we add to check the parameter and we put it on true. And finally, we add the JSON model that should be in there. That should conform to the model that we have in our stack. Those are all the methods that we will specify. So we have a couple of methods that you can call with an API key. And these will reject any calls that don't contain the API key or have an incorrect API key. And we have a couple methods that you can call without any API keys. So think about like a website, maybe you have some functions that you want to be able to publicly call. So everyone that doesn't have an account can look through a couple stuff, but you also have some stuff that you want to keep behind a security wall. I probably wouldn't use API keys for that, but maybe Cognito user pools, but it's just an example. If you do use like a computer system to computer system, then the API key is a very viable way. Or if you want to manage it more securely through the amount of calls, then also API is very good and suited way, because it's a way that you can manage also how often someone can make a call and how many calls, and also per period. And now that we're talking about that, that is actually the usage plan. So let's add also a usage plan, and let's go through what the usage plan contains. Like I said, a usage plan is a way to control the API key, and you can add a couple options. So we have a name and description. You add the API and you add the API stage, and the API stage, you can add a different stage to it. I am not doing that now, so I'm just adding the default deployment stage. Then you can add the quota. So you should see that the quota says how many calls you can do, and the period is over how many, over which time period you can do these kinds of calls. You also have the ability to throttle. So you can if there are too many requests, you can like reject them, and you can set the amount of how many or how many in a short while. We're not really gonna do a lot with them. I just put them in so that you know that you have these controls. And once you have a usage plan, you actually add your API key to this usage plan, and this usage plan will then be applied to your API, because we're putting the API here, and that is enough. So now let's first create an API key. And the API key is actually very simple to create. It's just like this. You can actually fill in the value yourself. I don't do that now because I don't know why you would do it. Maybe you do on a different kind of API key or a set, then you can do it, but it will create one by itself. And finally, we're gonna add this API key to our usage plan. So that's like usage plan, add API key, and we enter the API key. So now our infrastructure is done, and we need to add our Lambda code to the project. So I will create a new folder. We'll call it source. In there I will create a new file, index.ts, and I will paste in the Lambda code. Okay, and we need to install another thing, so I'm gonna do npm install add AWS, type/AWS Lambda, and we need to install this just to get the API Gateway event type. and okay, it's installed. So let's go through the Lambda code and see what it's doing. It's really simple Lambda. I don't really do much, but let's go through it from the top. So at the top, I'm importing an AWS API Gateway event, which will give us the properties to expect. So that this would be the event that comes in. So as soon as the API gets called, we receive an event, and the event will come into the Lambda, and we're saying, hey, this is something. For example, if it would be an SNS or SQS event, it will have a different format. And in the next line, line 2, we are deconstructing the parts in this event. So we're taking out the resource. The resource in this case is like /v1 open, /v1 secure, or /v1 secure param. Then the HTTP method. The HTTP method is the get, the post, the delete, and the patch, of course. And the parameters. These are the dynamic values in the URL, so it would be /secure, well, /v1 /secure, and then /Faruk in my case, if it was a name. Finally, the body. So if there is a body, we're going to take it out and we're going to look if we can find if there's a name inside of it. Then I have two functions. First one gets the name out of the object. So when we get the body, we're going to parse it as it is a string. Then we're going to take out the object called, well, the key in the object called name. And this should contain a string. If we have it, I'm only going to use it on the methods that should contain it. And as we are validating already with the request model and a request body validator, it should be in there. So I'm not checking here if it's in there. It's because I'm assuming that it should be there, or else the API should have rejected the request. Then in the next one, we're going to check in the parameter one. So here I am checking if there is a parameter, then I'm going to return it. If there's not a parameter, I will return false, because it can be that the path should also, we actually don't need to do it, but TypeScript is nagging. So it should not be possible to call that endpoint without a parameter. Then the next part is a switch for handling the different kind of requests to the resources. So we'll make a distinction between the open resources. All of these are not requiring an API key. So the get, the post, the delete, the patch, each of them will just get a 200 response code, meaning it went good, okay. And then the method, so the delete, the post, and was successful. Then for the other case, we will use the resource /v1 /secure. And here we had a post and a get. So if it's a post, we are expecting it to have a body. So that's why in the post, we also get the name from the body. And in the response, we will say, in this case, post on secure resource with name Faruk was successful. And if it was a get request, we will just return the method and it was successful on a secure resource. Then the final path of our API is the v1 secure and then the parameters. So if that resource was called, we also have a distinction between the patch and the other call. So in the patch, so this is the delete call. In the patch, we are actually expecting also some information because you want to patch something. So you also have to have some information that you can do it. Well, we expect it in the body, and just as the other one, well, the name should be in the body because we validated. So we're getting the parameter and we're getting the name from the body. So in my case, this will probably be Faruk and Faruk, but you could also have like the parameter be a customer number or anything else. So in this example, I'm not doing that, but that could be the parameter. And we return the method unsecure resource with parameter and name was successful. The final response that we have is the get params. So we're getting the params and we return it. So this would be a delete unsecure resource with param Faruk was successful. And if we don't find anything, which should actually not be possible as we've covered them with validators, then it should return that the resource was not found. And the response, so the create response, let's also have a look there. What does it do? We're putting in a code and a body. So the code is the response code, in this case 200. You have different response codes. You can also have a look at that. And the body in this case is what we want to send back. So this part here. And this is an object. So as you see, it is an object with a key and a string. But you cannot send strings, you cannot send objects in a response. So what we're going to do is we're going to take that body, going to stringify it and put it as a body. I have is-based 64 encoded on false. You can put it on if you want to put extra security in, but this is a tutorial. And I'm going to add some headers, really simple. So the response will contain these values. That is the Lambda code. Now that we have the Lambda code, we only need to do one last thing before we deploy. So in this bin, we need to add our environment stack files. Environment config. So so earlier we added the types to the lib. So here, that way we can access them here in our code because it knows it should contain the types. And what we're doing here is really injecting the config file values inside of our stack. So if you would want like a second environment and you want to have different values, you could add a stack like this and then change this file here. If you deploy, then you need to say CDK deploy CDK TS API Gateway stack 2, and it will automatically take the config file that's injected here. We are currently only making one stack, so I will remove this. But now that we have that in our stack, okay, and now we can start deploying. So let's open our terminal. We're going to do npm run build, which will compile our TypeScript into JavaScript. And because we put in the configuration in the tsconfig file, it will output all of this in the dist. So as you see, we created a new folder here. It will contain all the lib and the source. As you see, this is the Lambda. Now that we have that, let's deploy it into our account. So CDK deploy. Looks okay. Then we're gonna deploy it. Okay, we have a successful deployment. And what you see here, we can get also a link. It's the link to our API, so we can copy it. And now we can go to our AWS account to get our API key, and then we'll go into Postman and test out our API and check if everything's working. So let's switch. So I've logged into my AWS account, and to go to our API Gateway, we're gonna go to the API Gateway. And here the demo REST API, I'm gonna click it. And here we see the resources that we've created. So we have the V1, which is the root. And well, actually this is the real root. This is like my root. And then we have open, secure, and we have a parameter resource. And if we click on them, we can see that open does not require an API key, but the secure endpoint does require an API key. And where is this API key? Well, you find it here under the tab API keys. the demo API has the demo API key. And here we see also that it's connected to the usage plan we created, which also has the API that we want and the current stage of the API that you can use it for. And if we press here show, you can see the API key. And just like other keys, you should not share this with other people, but I'm gonna delete this API after the tutorial. So we copy the API key, and then I've already downloaded Postman on my computer. I will go to Postman, and in Postman, I will create a new environment, and the environment I call it Demo API Gateway, and I will have two variables there. So first I will have an X API key, as that is where the API expects the API key to be, and then I will also have one for the endpoint. So the current value we will paste in the API key, and the endpoint we should find here in our project. So I'm gonna copy this as well. I'm gonna go back to Postman, and this is our root resource, but because we appended the v1 to it, I will also append v1 here, and then slash. Okay, now we'll save this. Then I will go to the collections, and I will also create the collection for this. I will go through each of the calls, so you can also create them at home. So in the open calls, it's just a call, so we don't add anything. It's just the endpoint, so this will get the endpoint out of the environment variables. So this should be the domain slash v1, and then open. So let's call it and see if it's working. And the result we get is get on open resource was successful, so that's good. We get a response from the Lambda. Then let's try the post, which should be the same. These all are the same, so that should all be the same. Then next I'm gonna do invalid put method. And as I said earlier, we had specified that put is not one of the valid methods. So we were doing get, post, patch, delete, and not put. So let's see what happens. It says missing authentication token. Okay, so it got rejected by the API. Then let's see for the secure endpoints. And in the secure ones, so we don't have any parameters. We also have the endpoint, but this time it's to secure. And we do need to add the API key here. So API key we add here under authorization. We add the type API key. We say the key of the value in the request. So the API key is expecting our API key in x-API-key. And here we get the value from our environment variables. So this is the API key that I just got from the AWS console. The rest we don't add anything here. So this should be everything that we have now. Let's try it out. So the get on secure resource was successful. So that means that also with the API key we are managing to get the resource. But just to be sure, we have another request here with no API key, and we're going to try to call the same resource. So this time we're getting an error. 403 could not be a bad request. So as you see that without an API key we are not able to call this endpoint, but with an API key we were able to successfully call it. So now let's test the post method. And the post method, as I said, with the post method you are sending some data to the server. So in the post method we have our API key, and it's added to the header, but we also have a body. And as I said, my name is Faruk, so I will be adding the name Faruk, and this will be validated against the model that we created in our stack. So it's expecting this there. And if we look in the headers, so it's all the same. Well, let's send it and check if this will work. and we get the result positively. Result post on secure method resource with name Faruk was successful. So the Lambda was able to receive the request, route it to the right path, and there we got the name out of the name key, and that was Faruk. So far all good. And now we move on to the parameter variables. So now we have an endpoint, we have the secure, and then we have slash, and here will be our parameter. And as I said, the parameter is dynamic, so this can be anything, well, not anything, but it should be, in this case, Faruk, or another name could also be fine. Let's send it, and we're expecting that this time Faruk will be picked out of the parameter. So we don't have a body, we are adding an API key, and that's all it. So we're still expecting to receive it back with my name. So we're sending it, and the result is get on secure resource with param Faruk was successful. So we were able to recognize that it was to the param endpoint, and then take out this out of the request, and well, respond back to us through the API. Then we have our patch, and in the patch this was the one that we uses both the parameter and the body. So we add the API key just like the other ones. We should also add the body. It should be the same as the post actually, so let's copy that in. Patch. So we are sending, in this case we're sending 2 times my name, so 1 time in the parameter and 1 time as a value for the name key. And here we are expecting that it will be validated through both the parameter and the body. So let's send it. And the result that we're getting is patch on secure resource with param Faruk, and name Faruk was successful. So as you can see, both of them came true. This one was in lowercase, this one with the capital case. So the final type, well, this actually kind of sort of tested it, but this is the one without the body and only a parameter. And here also we get delete on secure resource with param Faruk was successful. So there you have it. We tested all our methods, and it seems that our Lambda is receiving all of our events and responding back to the client with the response. I hope you liked it. If you have any questions or missed anything in the tutorial, please leave a comment and I will try to edit. And if not, thank you all again for subscribing. And if you're not subscribed, please like and subscribe. Until next time.